Hey folks, in this video we're going to be looking at the new try syntax in Gleam 0.9. Gleam is a statically typed language that compiles to the Beam, the Erlang virtual machine. It's quite a young project at this point, but it's really promising and really interesting because there aren't a huge number of statically typed languages in that space, and a lot of people would really like to use the power of the Erlang virtual machine and have a statically typed language to work in. We're just going to have a look at a little bit of the language, so the new try syntax that's been introduced in 0.9 that's recently come out, and just have a look at how it helps us manage result types, handle errors, and clean up the code in general. Let's take a look. Okay, this is a small Gleam module that I've written. We can see that the syntax is inspired a little bit by Rust and maybe a little bit by Elixir, a little bit by Elm. At the top here we've got the imports, so we're just pulling in some modules from the standard library. IO module to allow us to print some things, map to provide an associative data structure, and the result to allow us to manipulate result values. The aim of the code in this module is to do lookups in a couple of different maps and combine the values that we get back into a tuple. The maps we're using are defined down here in the main function. They both have 2 entries each, and the idea is that we can look up by ID the name and the preferred sport of a particular person. As we can see below, we're trying to extract the name and sport for ID1, ID2 and ID4. The design here is that ID1 should succeed, ID2 should fail because it can't find the sport, and ID4 should fail because it can't find the name. If we compile and run this code using a basic mix setup, we'll see these results. So the first entry here, we've successfully found Alice and football. The second entry has failed on sport, and the third entry has failed on name. If we return to the code, we can see how this actually works. From examining this extract by ID function, we can see that we attempt to get the name first from the map, and if that errors, we return the error straight away. But if we're okay, then we attempt to extract the sport as well, again returning if that errors, but otherwise combining both the name and the sport into a tuple that we return. So this works fine, but it's a little bit clunky, and it would be nice to explore some other ways to achieve this. We should also note these 2 helper functions up above, which allow us to extract the values we're looking for from the map and convert what's returned into a result in the format that we want. In this particular case, it's either going to be the name successfully found or some kind of error message as a string. So another way we might implement this extract by ID function is to use the methods in the result module to combine the different results. We could do this with result.then, so we could focus on using extract name first and then piping it through result.then. If we use this to extract the successful name value from there and combine it with the sport using yet another pipe and the map function, we'll end up in a situation where we have both the name and the sport, and we can return a tuple of them both. If we just check that this compiles and runs, we can see that we're getting the same result as we were before. This does work, but it doesn't look great. We still have a bit of indentation. You can imagine if we had more operations, this would start to have even greater levels of indentation. We also struggle to see exactly what logic we're trying to implement here, because a lot of the code is more associated with managing the types and combining them than with doing the work itself. To improve this, we could have a look at how the try syntax that's been introduced in Gleam 0.9 attempts to improve these situations. The try syntax is quite simple and easy to use. We're really going to want to just keep the main parts of our logic here that we're interested in, and then we can use the try syntax to greatly simplify what's going on. Now we might hope that this would work as it is, but it doesn't, because by using the try syntax we're explicitly stating that this function is handling and returning result values. So in order to return a successful result here, we want to wrap this final value in an OK. From here we can see that when we compile and run this again, we get exactly the same results, but the final code is a lot clearer and easier to understand. And to reinforce our understanding, we're going to go through this line by line to make sure we understand what's happening. Here on this first line we're calling extract name that is returning some kind of result. In the situation that the result is an error, then this entire function is going to return here, right? Extract ID isn't going to go any further. And it's going to return an error value with the string up here. If it's successful, i.e. the extract name function returns an OK value with the name inside it as a string, then this syntax is going to unbox that OK, so it's going to pull the string, that name, out of the result type and assign it to this name variable here. So this name variable is going to be of type string, it's not going to be a result in this case. On the next line we're going to repeat the whole operation. So the extract sport function is either going to return an OK or an error. The error case, this whole function is going to return at this point with that error value. But on the OK case, the name of that sport is going to be extracted and stored as a string in this sport variable here. Finally, with these two values accessible, we can move on to the return line at the end here. This is the value that the function extract by ID is returning. And it's a tuple of the name and the sport wrapped up in an OK result value. And it has to be a result value because Gleam is strongly typed, so this function has to return the same type no matter where it returns. And as we've already seen, it's capable of returning a result type in these two lines in the case that it encounters an error. So it's either going to return an error in these two lines or an OK value here. And for further understanding of what's going on, because the Gleam compiler generates Erlang code, we can go and have a look at the Erlang code that's generated. Now, I'm not an expert at Erlang at all, but we can see in this function in the middle something very similar to that early case statement structure we had when we were using case statements in Gleam itself. So it's just compiling this try syntax to the case statements we originally had, allowing us to generate the same logic using a much cleaner syntax. Thank you for watching. I hope you enjoyed the video. Don't forget to like and subscribe if you want to see more, and if you have any questions or if there are any topics you'd like me to tackle in future videos, please leave a comment below.